So I know I did things a little backwards than was in the textbook and had you go over right triangle trigonometry 4.3 before we went over 4.2, which is the unit circle. Because I think the information in 4.3 is what you are familiar with when you learned some trigonometry, perhaps in high school. What I want to do now with the unit circle is take the information that you learned about angles and radians, take the information that you know about right triangle trigonometry, particularly the relationship of SOHCAHTOA, what sine, cosine, and tangent, what those ratios actually represent, and kind of combine them to really look at what trigonometry is. And when we define trigonometry and we define our trig ratios, we do it around what we call our unit circle. So in section 1 you learned about angles and moving them around an axis. So we're going to have our XY axes. We have a rectangular coordinate system. And I'm going to take an angle. And I am going to call that angle T. Now, where does the unit circle come in? Well, a unit circle, as you know, is a circle that has radius 1. So, if I draw a circle that has a radius of 1, I'm going to make it nice and big. So that means that's 1, that's 1. This over here would be -1. Of course, that would be -1 on the y-axis. But everywhere that particular circle has a radius of 1, so that means the distance from the origin to there is 1. Now, if you were to draw a triangle that touches the unit circle, hypotenuse stops at the unit circle, all right, and this would be, let me move my T down here so we remember we're dealing with angle T. Let's think about this particular triangle. Now we know the hypotenuse of this triangle is always going to be 1. The length of the base out to the right angle, well, that's whatever our x value is. And here, well, that's going to be our y. And of course, the point is whatever x comma y is. So now we can use that information and use what we know about relationships of our trig functions to look at the definition of our trig functions in terms of the unit circle. Now, what does that mean? Well, these particular definitions only work when you're working around a unit circle, by the way, okay? And you'll see why real quick. So let's start with sine. Well, sine of our angle T, we learned in the last section, sine is opposite over hypotenuse. Opposite is y, hypotenuse is 1. Y over 1 is simply y. Cosine then, and hopefully you can see where this is going, adjacent over hypotenuse, which is going to be x. Before we do the others, let's stop and think about that for a second. So that means if we have a unit circle, and only if we have a unit circle, meaning the hypotenuse of our triangle, is 1, then this coordinate xy, well, what is x? X is cosine t, can be written as cosine t is equal to the x value, and sine t is equal to your y value. Well, that's going to come in handy, especially if we are working around our unit circle. So on a unit circle, a coordinate of the point where your angle goes through, the x is simply equal to the cosine of the angle, and the y is equal to the sine of the angle. So knowing those two, we can kind of finish our other functions here. Let's continue to go around the unit circle. And let's do tan next. Tan of angle T. Well, tan we know is opposite over adjacent, so that's going to be y over x. And for the other ones, we can just do our reciprocal functions, of course. Reciprocal of sine is cosecant. So that would be 1 over y. Secant, 1 over x. Not as interesting, but also good to know. And then, of course, cotangent equals x over y. So this actually leads us, before we go any further, I want to talk about the fact that tan, for a second, is y over x. Whoops, tan of t. Forgot to put my t in there. Let me do that. Well, we already said that y is sine, x is cosine. So therefore, that's a symbol for therefore, 3 dots. Therefore, we can say that the tan function of any angle is equal to the sine of that angle divided by the cosine of that angle. And similarly, cotan of any angle, that starts with their x, so that would be cosine, plus we know it's reciprocal of tan, over sine. These are what we call our quotient identities. These two will come in handy throughout this course, throughout many of the courses you're going to take in mathematics, actually, especially in calculus. So these, well, you're going to want to memorize these. So far you know your reciprocal identities, the relationship between sine, cosecant, cosecant, secant, and tan and cotan. Those, of course, are called your reciprocal identities. Now you know your quotient identities. So 2 more identities that you really do need to memorize. And in fact, I'm going to use this unit circle to come up with one other identity. Why we're here. And this one comes from the equation of a circle. In previous math courses, you learned the equation of a circle that is centered at the, now this circle is very specific because it is centered at the origin. It actually simplifies our equation, because normally you'd have x minus whatever the coordinate is and y, but we don't need to do that because we're at 0. Equation of a circle is simply x squared plus y squared equals radius squared. Oh, but it's a unit circle. So in a unit circle, x squared plus y squared equals 1. Well, we've already learned that x is cosine. Y is sine. And the radius, of course, is 1. This leads us to another pretty important identity. I'm going to rewrite it a little bit. Number 1, I'm going to start with the word sine, just more common. So I'm just going to rearrange cosine and sine. And do you see how the squared is outside the parenthesis? Well, I'm going to take that squared and I'm going to move it, write it like this. So a little note to yourself, sine squared of any angle is the same as writing sine of that angle squared. All right, it's just an easier way. Keep in mind, that is not sine theta squared. Sine theta squared is a completely different problem. But sine squared theta and the parentheses sine theta squared are the same thing. It's just the square is kind of the more acceptable way to write that particular when you square a trig function. Either way, this leads us to another really important identity. something else you do need to memorize, and that is your Pythagorean. So there's your Pythagorean identity. Now if we rearrange and play with that sine squared plus cosine squared identity by turning it into reciprocals and doing a whole bunch of algebra, which we will not do at this moment, you get two other Pythagorean identities using our other trig functions. The other one is 1 plus tan squared t equals secant squared t, and 1 plus cotan squared t, oops, not cosine, sorry, cotan, equals cosecant. So here are two other versions of the Pythagorean identity that you must also memorize. So I'm kind of giving these to you now. We will come across them and use them at various times in the class, but it's a good time to kind of start memorizing these relationships. So what does all this mean? Well, it's got a lot of different purposes. Let's take a look at, start with something a little more simple. Let's suppose that we have, we'll do an example. And for this particular example, let's suppose we have a unit circle. So we're going to draw a unit circle. And I'm going to put a point on this unit circle, but I'm going to put this point out here in quadrant 2. Well, quadrant 2, and I'm going to call this point P, and it has the coordinates of, let's see, clearly it's in quadrant 2, so the x has to be negative, so we're going to make that negative 1/2. And we'll call the y value square root of 3 over 2. So what does that mean? Well, that means there is an angle that exists, right? That goes to that point. Such that, we'll call this angle T, right? Based on what you just learned, sine of T would have to equal, so keep in mind, sine is the y value, square root of 3 over 2. And from here, given just one single point on a unit circle, you can actually find the trig, all 6 trig values. Cosine of t, well, cosine of t is negative 1/2, because we know that's the x value. And this problem will help us also to recall how to do some simplifying. Tan of t. Well, to do tan of t, we need to do a little bit of work. We know tan of t is y over x. Well, so it's square root of 3 over 2 divided by negative 1/2. And we can simplify that particular problem by multiplying by 2 over 2. When you multiply, basically you can right, multiply by 2 over 2. It'll cancel the 2's in the two denominators. And we end up with square root of 3 over negative 1, or simply negative square root of 3. And then cosecant of t. Well, that's a reciprocal identity, so it's going to be the reciprocal of whatever sine is. So that one's going to be 2 over radical 3. We do not leave radicals and denominators. We do rationalize our answers. So that's radical 3 over radical 3. So it becomes 2 radical 3 over 3 is the answer for cosecant. Secant t is going to be 1 over x, right? Because it's the reciprocal of cosine. Cosine we know is x. So secant's 1 over x, so it's 1 over negative 1/2. 1 divided by negative 1/2 is 1 times the reciprocal of negative 1/2, which is 1 times negative 2. And that, of course, is going to come out to negative 2. And then cotan. So, well, we can start by doing x over y, or you can just do the reciprocal of here instead of doing all that other work, which would give us negative 1 over square root of 3, which of course we do have to rationalize. So cotan ends up being negative square root of 3 over 3. So given that one single point, we can actually utilize our new definitions for our trig functions on a unit circle. Now, why can we do this? Because you are actually given a unit circle. So you would have to be given P is a point on the unit circle. If you are not given a unit circle, then this particular set of definitions does not work, because remember, those definitions only work when you're working in a unit circle. And we'll be going over that in the next section. So there's actually a lot of other things we can come up with based on this unit circle definition. For example, it is often helpful to know in which quadrants are trig functions negative or positive. So for example, think of that unit circle and think of various points. So the first point I'm going to do is in quadrant 1. Well, in quadrant 1, all x's are positive and y's are positive, correct? So let me just write that as you're going to have some positive value and some positive value. Well, think through the 6 trig functions. If the x and y are positive, well, that means sine is positive because that's y. Cosine's positive because that's x. Tan is going to be y over x. Well, positive over positive is a positive. Reciprocals are all going to be positive because the original trig functions are positive. So in quadrant 1, you can say that all trig functions, sorry, you heard my dogs in the background, they're excited about something. Are positive. That's very helpful, very useful piece of information. How does that change when we go to quadrant 2? So go ahead and put a point in quadrant 2, and let's think about that point. Well, all the x values in quadrant 2 are negative, right? But my y values are positive. What does that do to our trig functions? Well, let's go through each of them. Sine is the y. Well, the sine is positive. If sine is positive, that means cosecant has to be positive because it's the reciprocal. Cosine, though, is the x. That's negative. Tangent is y over x. One of them's negative. That's going to be negative. In fact, the only trig functions that are going to be positive in quadrant 2 are sine. And of course, it's reciprocal cosecant. Now, go to quadrant 3. in quadrant 3, if I put a point, right? What happens? Both x and y are negative values. Everywhere in quadrant 3, x and y are negative values. So that means your sines are all negative, reciprocal cosecants are negative, your cosines are negative, and your secants are negative. But what happens with tan? Tan is going to be the y over the x, negative over a negative, which is always going to be positive. So only tan and its reciprocal cotan are positive. Everything else is negative in quadrant 3. And then you can clearly see then that in quadrant 4, which is going to be positive x, negative y's, that leaves us with cosine and its reciprocal, of course, secant, are positive. This is going to be really important to kind of, in some ways, to a check for your answers. So if you're dealing with an angle that falls in a certain quadrant and you had to find the cosine of it, you can kind of check your answer at the end, be like, oh, good, yeah, it is positive or it is negative as it should be. So it is important to understand. I'm not saying you need to memorize this. You can kind of think through it. You don't really need to memorize. Though, I believe when I went to school, we were taught starting at quadrant 1, all students take calc, all trig functions, students stands for sine, sine is positive, t in quadrant 3, take calc. See, I know, silly, but that's how we memorized it. So do kind of think through the unit circle to determine when things are positive and negative. The other thing we want to use the unit circle for is to think about our domains. So let's particularly think about the domain of sine and cosine. First, sine and cosine. And the domain is something we'll discuss in more detail in the second half when we get prepare for test 2, which is the second half of chapter 4. We're actually graphing these as functions, not on a unit circle. All right, so when you think about our unit circle, again, 1, 1, negative 1, negative 1. And we know that y equals sine of t. So our y values are only going to go between 1 and negative 1. So that means the domain for a sine function. Now, when I talk about domain, I am talking about the values that you can input into the function. Our input values are going to be what we can plug in for t in this case. These are our input values. In other words, this is our domain. Well, we learned in the first video that when you draw an angle, you can go around and around and around and around and around. You can also go negative, around and around infinitely many times. So we can input any angle measure we want, radians or degrees. We can input any angle measure. So if we can input any angle measure all the way from the lowest negative to the lowest positive, wouldn't you say the domain is negative infinity to infinity? Now, the range is our output. It's those y values. You can clearly kind of look at the graph there. It's a ratio. Even if we expand this past the unit circle, we're still looking at a ratio of opposite sides over hypotenuse. And no matter what, that ratio can only be between those values 1 and -1. So our range of our function, now it can include 1 and -1, so we write it like this. In fact, cosine is going to be very similar. Where you can input any angle. But you can see by the x's, you are also only looking at 1 to -1. So both sine and cosine, have a domain of -infinity to infinity, meaning you can input any single angle you want, again, whether it's radians or degrees, and have an output or a range between -1 and 1. So that's another little piece of information you kind of want to memorize and make sure you know. The other thing we can do with our unit circle is really look at the values of what we call our quadrant angles. And I go back to my 1, 1, -1, -1. Part of what you're going to do in this class is learn how to get values of trig functions without the use of a calculator, and also get values of trig functions with the use of a calculator. But we always ask for what we call exact answers, and very often you need to know your quadrant angles without plugging anything into a calculator. All right, so what do we mean by our quadrant angles? Well, the first quadrant angle I'll mention is 0 degrees, or 0 radians. 0 radians, just a 0 without the degree symbol. So think about what that particular angle looks like. Well, it doesn't move. The terminal and the initial side fall right there. So what is the coordinate? That coordinate, let's look at coordinates instead of just those values. So that would be 1, 0. Coordinate here, 0, 1. Coordinate here is -1, 0. And the coordinate here is 0, -1. So when you're looking at 0 degrees, you're falling right here. So simply, let's draw it like this. I will not do the reciprocal functions. You can kind of figure those out on your own. Okay, so let's do the first one. 0, sine. Sine is your y value. Well, that's just 0. Cosine is your x. That's 1. And tan, of course, is y divided by x. 0 over 1. So sine is the y. Cosine is the x, and tan is y over x. Again, working in a unit circle makes it easy. So tan is y divided by x. That's 2 is 0. Now, the next angle we're going to talk about is this one up here. This is your pi over 2, or 90 degrees. Pi over 2 radians is 90 degrees. Okay, let's look again. Sine is y, well that's 1. Cosine is 0. Tangent, 1 divided by 0. That is what we call undefined. The tan is actually undefined at 90 degrees. We get into the graphs next semester, at the end of this unit. Hopefully you'll remember from Pre-Calc 1 what happens when a graph is undefined. We have something called an asymptote. So when we actually graph our tan functions, you will see that they have asymptotes. All right, the next one, going around our unit circle, is 180 degrees, which is pi. (180 degrees) or pi. So again, sine goes to 0. You can easily see -1, and that's 0. Next angle is 3 pi over 2, or 270 degrees. And once again, just looking at the coordinates, 0, -1. Sine is now -1. Cosine is 0. And tangent will once again be undefined. And this would take us back to, we know this is 0, but this is also 2 pi. So we'll stick that one in there, which is either 360 degrees or 2 pi. And that is going to have the same exact answers as the 0 degree. All right. So you can use the idea of your unit circle to get any quadrant angles. Quadrant angles are angles that fall directly on a quadrant. These are not all the quadrant angles. There's infinitely many. Negative pi over 2 is a quadrant angle, but negative pi over 2 would be equivalent to 3 pi over 2. Negative 180 and 180 end up falling at the same angle. Negative 3 pi over 2 would be equivalent to pi over 2. So depending on your quadrant angle, you can use your idea of a unit circle to kind of get those values. There is a couple more identities we want to take a look at.